welcome to your 5th lesson. In our lesson today, what we're going to be talking about is negative exponents. So our objective is to simplify expressions that involve negative exponents. Our standard for today is 8th grade standard equivalent expression standard number 1. Let's go ahead and get started on today's lesson. In today's lesson, we have 2 key concepts that we're going to talk about. The 2 key concepts we're going to talk about is the zero exponent rule and the negative exponent rule. Any number to the power of 0 will be 1, as long as that number is not 0. Because 0 to the power of 0 is actually 0. 0 times anything is always 0. So any number besides 0 to the power of 0 will always be 1. So an example of that is if I have like 5 to the power of 0. That's 1. If I have 256 to the power of 0, that's also 1. If I have 1,000,000 to the power of 0, that's also 1. Now, a negative exponent is when we have any number to a negative exponent, it's going to be equal to 1 over that number to a positive exponent. So here's an example. If I had 5 to the power of negative 3, what I could do is I could put a 1 on top, that's 1 over that same number, but now the exponent's positive. So what happens is 5 to the negative 3rd power is going to equal 1 over 5 to the positive 3rd power. Whenever you have a negative exponent, that actually becomes a positive whenever we put it on the denominator. Let's go ahead and look at another example of why this works this way. So go ahead and make sure you have this on your notes, but we're going to look at another example of how I can explain this a little bit more for you. One of the ways that I can explain negative exponents to you is by looking at the number 2 and looking at it in many different exponents. So what we're going to do is we're going to change these to their proper way of being written. 2 to the 2nd power means 2 times 2, which is 4. 2 to the 3rd power means 4 times 2, which is 8. 2 to the 4th power means that we're going to have 2 times 2 times 2 times 2, which really means we're going to take 8 and multiply it by 2 and get 16. 2 to the 5th power will be 2 times more than 16, which is 32. And 2 to the 6th power will be 2 times more than 32, which is 64. Now, I know that you're looking at this and you're probably like, well, that doesn't really explain negative exponents to me. And that is true. But before we get to negative exponents, let me explain to you why a number to the power of 0 is 1. So, if we're going to the right, what's actually happening is numbers are multiplying by 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, 32. 32 times 2, 64. But what were to happen if we were to, instead of making the exponents go up, make the exponents go down? Well, 64 instead of times 2, but 64 divided by 2 would bring me to 32. 32 divided by 2 brings me to 16. 16 divided by 2, 8. 8 divided by 2, 4. So this means that 2 to the 1st power would be the number 2. So what's happening is we're going to go backwards by dividing by 2. Now, one rule that I know I didn't cover, any number to the power of 1 is always going to be itself. So this is a rule that we should know, because what's actually happening is if you see one of them, that means it's to the 1st power. And if you see a different power, that means you're multiplying by itself that many times. Well, 2 to the power of 0 means that we would take 2 divided by 2, or we take any number divided by itself, we'll always get the number 1. And this works with 3s, this works with 4s, 5s, 6s. It doesn't matter, because whatever you're multiplying going up, you're going to divide by going backwards. So any number to the power of 0 will be 1, because if we think about exponents instead of going up, going down, we'll always end up at 1 whenever we get to the power of 0. Now here's where we're going to talk about the negative exponent rule. The negative exponent rule says that if I have a number like 2 to the negative 1st power, this answer should be 1 over 2 to the 1st power. Well, 2 to the 1st power is 2. So what that means is that this right here should be 1 over 2. 2 to the negative 2, if we're following the rules of exponents, since that's a negative, all we got to do is put a 1 on top and get rid of the negative sign. This right here would actually be 1 over 2 to the 2nd power. And if we look at our chart, 2 to the 2nd power is 4. So this would be 1 over 4. And if you notice something, there's actually a pattern happening here. It goes 1, 2, 4, 8, 16, 32, 64. And they match up with the numbers that we have up here. Well, now if you look, the number is 2 to the second power. That's 2 to the second power. We got 4. The next one would be 2 to the negative third power, which means that we would have 1 over 8. Now, if I wrote it as a positive exponent, I would say that 2 to the negative third power is really 1 over 2 to the positive third power. So in this lesson, what you're going to be learning how to do is you're going to learn how to take a negative exponent and make it positive, take a positive exponent and make it back negative. That's what we're going to be learning in this lesson, as well as how to multiply, add, subtract, and divide with those. So make sure you pay attention to today's lesson, because this is what we're going to be going over, but we're going to be doing it mathematically. I'll start one more time. Kill me here. Last try. Last go. In example 1, we're going to be talking about how to change a negative exponent to a positive exponent. But we're going to use that key concept that we covered about 2 pieces back. It says write the expression using a positive exponent. Okay, so we have to change this exponent from a negative 3 to a positive 3. That's really all it's asking us to do. Well, if you read the key concept says in order to change a number that's negative, or an exponent that's negative, what you want to do is you want to make it 1 over that same number to the positive exponent. So 6 to the negative third power would become 1 over 6 to the third power with a positive exponent. And I covered the reasons why that works when we looked at the 2's. It works the same as when you do 6's, 8's, 9's, 10's. It doesn't matter what the number is to any exponent. What happens is instead of multiplying going this way, you'd be dividing going the other way, and you ended up with the same number that you had whenever you looked at the exponents going positive, but now instead of the exponent being on top, it's now on bottom. So 6 to the negative third power, all we do is change it to 1 over 6 to the positive third power. Let's go ahead and try another example and kind of put this a little bit more at ease. Alright, in example 2, we're doing the same thing. We're going to change this to a positive exponent. We're looking at 4 to the negative fourth power. The rule says, again, if we have a number to a negative exponent, all we got to do is change it to that same number under the number 1, but now instead of it being a negative exponent, it's now a positive exponent. So notice that instead of it being a negative 4, it's now a positive 4. All you got to do is make it the same number under 1, but change the exponent to a positive. Let's keep going. When it comes to variables, it's no different. We follow the same rules of our key concept whenever it's a number, because a variable is a number. So if I had a to the negative fifth power, and the directions told me to write the expression using a positive exponent, all I would do is write it as 1 over a to the positive fifth power. And remember, this is just because of the rule of when we see something going up, we go backwards by doing the same thing. So it's 1 over a to the fifth power. A negative exponent becomes a positive exponent on the bottom underneath 1. In example 4, I'd like you to pause the video, copy down what's on the board, and see if you can answer it on your own based on the key concepts in the previous 3 examples that we talked about. Hopefully you're understanding how this works. So, hopefully you looked at this problem and you were able to get an answer. The answer that I believe that you should have is 1 over c to the 7th power. Reminder that an exponent that's negative, all you got to do is put a 1 on top and make that exponent positive on the bottom. So any number that has a negative exponent, you can change by having a 1 on top and a positive exponent on bottom. In example 5, what we're going to do is we're going to flip things around. Instead of changing from a negative exponent to a positive exponent, what we're going to do is change from a positive exponent to a negative exponent. So we're going to kind of go backwards from where we were. So in this problem, we have 1 divided by 5 to the 2nd power. Now notice that 5 to the 2nd power is positive on the bottom. So what we're going to do is we're going to change it so that way the exponent becomes a negative. Now one of the rules in the directions say though is that we're not allowed to have the exponent to be a negative 1. So we have to use any other number other than negative 1 as our exponent. Well in this case we're lucky because 5 to the 2nd power would be 5 to the negative 2nd power. All we got to do is take away the 1 and change the exponent back to negative, because we know that if we had 5 to the negative second power, if we wanted to make it positive, we'd put a 1 on top and rewrite it as 5 to the positive second power. So in this case, this is our answer. Notice our exponent is something other than negative 1. Let's see if we can do another, and maybe you can do it on your own, so pause the video and see if you can do it. But if you can't, that's okay. I'll walk you through it, and then we can practice in class. In example 6, we're going to be solving a problem that says write 1 divided by f to the 5th power using a negative exponent. So what we need to do is we need to change this positive exponent to a negative exponent. Now we just did it with the number 5, so hopefully you're feeling pretty confident. Now reminder, it's something other than 1. So in this case, we could rewrite it as f to the negative 5th power. And what we're doing is we're thinking about the rule. If we had the letter f to the negative 5th power, if we needed to change that to positive, we put a 1 on top and make it f to the positive 5th power on bottom. So in this case, instead of going from here to there, we're going from 1 over f to the 5th power to f to the negative 5th power, kind of just going backwards. So hopefully you're understanding this. We're going to practice a few more things and see what happens. In example 7, it says that we're going to write the fraction as an expression using a negative exponent other than negative 1. And so this is one of those cases when we see this problem, a lot of students are going to be like, okay, well that's 36 to the 1st power, and if I want to make that a negative exponent, what I would do is I'd make it 36 to the negative 1st power. And technically that would be okay, but in this case it's not, because the directions say that we're going to rewrite this using a negative exponent other than negative 1. So what you have to do now is, instead of doing this, you have to look at, well, what makes 36 that could be some type of number that's exactly the same multiplying by itself? Hopefully you know your multiplication facts and you know your perfect squares, because in this case, the number that would make 36 would be 6 to the 2nd power. And that's because 6 times 6 is 36. So what we could do is we could take 1 over 36, and we could say that it actually equals 1 over 6 to the 2nd power. Well, 6 to the 2nd power, that's a positive exponent on the bottom, which means that if I wanted to make it a negative exponent, I'm going to make it 6 to the power of negative 2. So in this case, if you're given a number and you're not allowed to use negative 1, what you want to do is you want to look at that number and say, can I figure out what numbers multiply to make that are exactly the same? And when you get those numbers, that's the number to the exponent that you're going to be using. Now remind you that it's a positive exponent on bottom, which means that it's going to become a negative exponent when you take away the 1. In example 8, we're going to do kind of the same thing that we just did in example 7. In this case, we have to write this number using a negative exponent other than negative 1. So again, we can't write that this is 9 to the negative 1st power. What we have to do is we have to think about what numbers exactly the same do we know we could multiply a couple times and get 9. Hopefully you're thinking about the number 3. 3 to what power is 9? 3 to the 2nd power. So in this case, we could change 1 over 9 to 1 over 3 to the 2nd power. Now notice right now all we did was change this to exactly what it is equal to. 3 times 3, that's 9. And we have an exponent now, which is great because we need that exponent. We're now going to rewrite this using a negative exponent, but it's not allowed to be negative 1. And that's okay because the number we have here is 2. So we would rewrite this as 3 to the negative 2nd power. And that would be our correct answer for this one. In example 9, we're going to look at some real-life problems that we're going to change to exponential problems. So it says 1 human hair is about 0.001, or you could say that this is 1,000 inches in diameter. So 1 hair is 1,000 inches in diameter. We need to write this decimal as a power of 10. So in this case, if I was writing this as a fraction, I'd write this as a 1 with 1, and if you forgot that that's 1,000, what you could do is count how many numbers are behind the decimal. Well, there's 1, 2, 3, so that means 1 over 1, 2, 3 zeros. So if you ever need to remember how to write a number as a decimal and you can't actually say it based on a place value, what you do is you write the number you see, you put it over a 1, followed by that many zeros. So 1 human hair is about 0.001 or 1,000th inches in diameter. Our job is to write this number as a power of 10. So we have to think about the number 10. They already told us the number we're going to be using. So I'm going to write 10. 10 times 10, I know that's 100 because I add 2 zeros. Well, this has 3 zeros. So 10 times 10 times 10 will equal 1,000. So in this case, I need 10 to the power of 3. So this means that one human hair is 1 and 10 to the third power inches in diameter. And if they asked me to write this as a negative exponent, I would say that one human hair is 10 to the negative third power inches in diameter. So my answer would be this right here, because we've written it as a power of 10, and we wrote it as a fraction, and we wrote it as a number with the negative exponent. 10 to some power. That's what we're looking for. Let's try another one. In example 10, we're going to look at another real-life example. A grain of salt has a mass of about 0.0001 grams. Now, again, that's 1/10,000th gram. We need to write that decimal as a power of 10. So in this problem, we're going to rewrite this decimal as a power of 10. But first, we should change it to a fraction. So this is 1 over 1. Now again, if you didn't know that's 10,000, what you do is you count how many numbers are behind the decimal. Where there's 1, 2, 3, and just so you guys know, I don't know if you can see the decimal very well, the decimal's right there. There's 1, 2, 3, 4 numbers behind it. So what you do is make it a 1 followed by 4 zeros. So again, it's 1/10,000th gram of the weight. Our job is to change this to some type of exponent that has a power of 10. So what we're going to do is we're going to say, well, 10 times 10 times 10. We know this is 1,000, and 1,000 has 3 zeros. Well, this has one more, so we'd multiply by 10 again. 10 times 10 times 10 times 10. Well, that's 10,000. So what that means is 10 to the fourth power would equal 10,000, which is the number that we have on bottom. So 1 over 10,000 would equal 1 over 10 to the fourth power. And again, if we wanted to change that to a negative exponent, all we got to do is say if it's positive on bottom, it becomes a negative whenever we take away the 1. So we just wrote it as a power of 10. 10 to the negative fourth power would be our answer to this problem. In example 11, what we're going to do is we're going to start talking about how to actually multiply using previous rules that we talked about. So if I had 5 to the third power and I times it by 5 to the negative fifth power, reminder, if we're multiplying two numbers and they have the exact same base, then what we're supposed to do is add the exponents. So in this case, this means that we would take 5 to the 3 plus negative 5. So we're adding the exponents because of the fact that our bases are the same and we're multiplying. Well, 3 plus negative 5, hopefully you know your math, this is 5 to the negative second power. Now, this would be good, but I actually want to solve this problem because that's what the word simplify means. I want to get it as simple as possible. So what we're going to do is we're going to change a negative exponent to a positive exponent. So this equals 1 over 5 squared. And we talked about this in class and we said if that exponent's less than 5, we should probably change it to its actual number. So let's go ahead and do that. This will actually equal 1 over 5 squared, which means 5 times 5, which is 25. So 5 to the third power times 5 to the negative fifth power is actually going to equal 1 over 25, or 1 divided by 25. In example 12, we're still multiplying two numbers that have the same base. We have 4 to the negative fifth power times 4 to the negative third power. So what we're going to do is follow our rules based on this, the laws of exponents. If I have two numbers that have the same base and they're multiplying, all we got to do is add the exponents. So this really means that we're going to have 4 to the negative 5 power plus negative third power. Well, negative 5 plus a negative 3 will equal 4 to the negative eighth power. Now, one of the things about math that you'll come to understand is that a lot of mathematicians don't like it when we have a negative exponent. So we're actually going to change that exponent to a positive. So it's 1 over 4 to the eighth power. And since that exponent's larger than 5, we're just going to leave it as 4 to the eighth power. Let's do two more problems and call it a day. So in example 13, we're actually looking at two numbers that have exponents, but this time they're dividing. Now, we're looking at numbers that have negative exponents. The same rule still applies as what we've done in the past. When dividing two numbers with the same base, what we want to do is subtract the exponents. So in this case, if I had w to the negative first power, and I'm dividing it by w to the negative fourth power, what that means is we're going to look at the exponents, since we have the same bases, and we're actually just going to subtract those. So, w to the negative 1 minus negative 4. Now, in this case, we have to remember what two negative signs side by side mean. Hopefully you're thinking that they mean add. So we're going to change two negatives to a positive. So what actually happens is we have a negative 1 plus 4. Well, this actually means that our answer would be w to the third power. And we can go ahead and leave it as that because our exponent's positive, and that's absolutely what we want. One more problem, and you're done. In our final problem, we're going to kind of do the same thing that we just did in the previous problem. If you feel like you can do it on your own, by all means, go ahead, pause the video, do this on your own. I'm going to go ahead and solve this problem. So we have c to the negative fifth power divided by c to the negative 7. Again, we're looking at two numbers that have the same base, and they're dividing, which means we can subtract the exponents. So what we're going to do is take c to the negative 5 minus negative 7. And again, we have two negatives side by side, which means that we're really just going to change this to adding. So it's c to the negative 5 plus 7. Well, a negative 5 plus 7 means that I have two more additional. So this is c to the positive second power. Hopefully you have some questions based on this lesson. That's it for today. You guys did awesome. Make sure you have your notes, and if you can show me your notes coming in at the door, I will give you a sucker because you guys did great, and this hopefully makes sense to you. We're going to practice this in class, and you guys should hopefully understand. Ask any questions that you have, and we'll cover that. Make sure you like this video. Go ahead and click that notification bell, and if you haven't yet, go ahead and subscribe, and I will see you tomorrow.